Hi there, this is Reniel Mark Egatula, taking up Bachelor of Secondary Education major in Mathematics. This is a video tutorial on how to find out or how to evaluate the limit of a function using table of values and graph of a function. But before I start my video, let me first state the objective of this video. First, at the end of this video tutorial, the viewers would be able to understand or define what limit is. The second one, the students or the viewers will be able to evaluate limits using table of values. And the last one is the viewers will be able to evaluate limits using graphs of a function. Since I am done stating the objective of this video tutorial, now let us define what limit is. Limit is so-called the backbone of calculus. Why? Because limits are used to define many topics in calculus, such as derivatives, continuity, and integrals. And limits can be written in symbols like this one. And this symbol is to be read as limit of function of x as x approaches to c is equal to L. And now that we have defined what limit is, let us have our first example in finding the limit of a function using table of values. First, the limit of x squared minus 1 over x minus 1 as x approaches to 1. So let's find the limits using the table of values. For us to be able to find the limits of our first example, let us have two tables. Let us separate those tables wherein just like this table. Okay, so I have put the values of x here that is less than 1 but is still approaching 1. Then in this side, I have put the values of x greater than 1 but is still approaching to 1. So that we can have the limits of this function x squared minus 1 over x minus 1. So it is simple as it is. We are going to substitute the value of x into this equation. And if you have your calculator with you, you can try it. So if the value of x is 0, what would be the value of this function? Okay, I already computed it. So I am going to write it down here. Also here. Okay? Okay? Let me show you the values that I got when I substituted the values of x in the given function. And the limits will be equal to that answer. Okay? So, when x is 0, the limits is 1. When x is 0.5, the limit would be 1.5. If the values of x is 0.9, the limit of this function is 1.9. And if the value of x is 0.99, then the limit would be 1.99, which is approaching to 2. Also, in this part, if the values of x is 2, then the limit would be 3.01. And if the value of x is 1.5, the value of or the limit would be 2.5. And if the value of x is 1.01, our limit would be 2.01. And if our value of our x is 1.001, we will be having a limit of 2.001. And as you can see on the result, as you can see here, the limits will be approaching to 2. And also in this part is approaching to 2. So it means that when the limit in this side and the limit in this side are the same or approaching to one number, then the limit exists. Okay, now let us have another example. Okay, this example, limit of x squared plus 5 as x approaches to 5. So just like our first example, we are going to draw a table again, two tables, just like this one. Okay, I am encouraging you guys to please pause this video and try to find out what would be the limit as this x values were applied in this equation, x squared plus 5. Okay, pause it now. Okay, now let us find out whether you get the right answer or you get the answer just like mine. Okay, I'm going to show you now. Okay, when the values of x is 4, then our limit would be 21. And when the value of x is 4.5, our limit would be 25.25. When our value of x is 4.9, you can see that our limit would be 29.01. Then, when it becomes 4.99, our limit would be 29.9. Okay? Approaching to number 30. And this side, as x is 5.1, we get the value of 31.01. When the value of x is 5.01, we get a value of 30.1001. Then, when the value of x is 5.001, our limit would be 30.010001. And when our value of x is 5.0001, our limit would be 30.0010001. And as you can see, this limit is approaching to 30, and also this limit of the side is approaching to 30. It means that the limit x squared plus 5 as x approaches to 5 exists. Okay, and our last example, we have this example. Okay, limit of x cubed minus 3x squared over 5x minus 15 as x approaches to 3. Like this table. Okay, now it's your turn to solve this. Okay, as x is 2.9, 2.99, and 2.999. And in this part, 3.1, 3.01, 3.001. Okay, again, you can pause this video and try to find out what would be the limit as we substitute the values of x in this table. Okay, let me show my answer, and hoping that we got the same answer as I have here. Okay, this one. Okay, so as you can see here in my solution or in my answer in this table, we can see that the limit is approaching to 1.80, and they are both the same, that they are approaching to 1.80. So it means that the limit exists in this function.